I'm Mitch Marks, and I'm going to be talking about propulsion systems and electric aircraft and how we measure them. So electric aircraft might seem like a really far off concept, but we're increasing technologies for electric aircraft every day. So we're making aircraft that have multiple propulsion units. We're making aircraft with new novel geometries. And we're coming up with new unique control schemes for flight. This could be electric vertical takeoff and landing, or some other novel concepts. Now, one of the big issues we have with electric aircraft is how are they going to get up in the air and how are they going to go any sort of range? So if we look at an electric aircraft, we have range on the X and weight on the Y. As we increase our range, our weight needs to increase because these are battery-powered systems. But if we can decrease that weight, we can go farther with the technologies that we have, and we can go farther with a lighter aircraft. Now, the problem with this is that a lot of these technologies don't exist yet, but we're currently innovating them. But we can do some clever things in the meantime in order to reduce weight. We can create new motors that have really novel technologies and that have very low losses. They're extremely efficient machines. We can increase the fundamental frequency of our motors. And we can use modern switches for our inverters that are going to reduce losses. And we can operate at higher switching frequencies without the inherent loss. Now, the problem with these new technologies is that they often cause current ripple. This is where the current isn't necessarily perfectly sinusoidal. This current ripple increasing is going to result in a torque ripple increasing. And this torque ripple increase can actually couple to the wing of the aircraft and create vibrations. So the machine's going to vibrate, which is going to create the wings to the vibration. So our vibration is also going to increase with increased current ripple. Now, this creates a series of problems. This increased current ripple and these high efficiency motors mean we need to characterize the individual motors, the individual inverters, understand how they work, and understand how we can make those incremental improvement in efficiency so we can reduce the losses. We also need to characterize how those vibrations are being created, when they're being created, and how they couple to the wing. Because if we have a wing of an aircraft, it's going to be moving up and down, and it's going to create those vibrations. This can be very hazardous for the aircraft as we can enter a flutter mode, and this flutter mode can make the aircraft structurally unstable and possibly be a flight risk. Lastly, because we have multiple propulsion units, we need to look at this aircraft as a whole electrical network. We need to look at the power being supplied to each individual motor. We need to look at the DC bus and make sure that we're not creating electrical resonances that can also become a flight risk. And because of the number of motors, because of the number of AC networks, that can be potentially a very large number of measurements. So we have three main things we need to do: components, structures, and overall electric networks. HBK can help solve these measurement problems with our edrive power analyzer. The edrive system can make extremely accurate measurements so that you can really understand what the power usage of each of your components is. You can look at these individual motors and inverters and identify if one control technique is more effective than another. You can look at these very small differences in power usage to really trust you're going to get as much range as possible. The edrive system can also make a wide variety of measurements. Because these aircraft are electrical mechanical systems where we have voltage resulting in noise and vibration, we can measure voltage, current, torque, speed, noise, and vibration all in one common chassis. So you can really characterize how the battery gets transferred to the inverter, goes to the motor, and ultimately results in vibration of the machine, and understand how it can couple to things like wings for flutter. Lastly, the edrive system can make hundreds of measurements. This allows us to take the inputs and outputs of each individual motor and their resulting mechanical counterparts, so that we can truly look at the full system and understand if we're creating electrical resonances. The ability to take these 3 individual tests all into one system allows you to really quickly characterize your motor in a much more simple measurement environment. Thank you for your time.